Okay, so this is Troy Curtis. This is my intermediate heat transfer class term project. I'm just going to walk through how the code works and just explain what you can input and what you're going to get out of it. So first off, the user inputs are right between these two commented sections. So anything in here you can basically change to whatever you want. So for example, there's the base temperature. There is the conductivity of the fin material. Pretty easy stuff. I even put in what units you're going to need, like degrees Celsius. Don't put in Kelvin. This is ambient temperature of the fluid around the fin, the convection coefficient of the air around the fin, stuff like that. I also put in the number of fins, the width of the plate. Since it's a square plate, you just need one side of it. The thickness of the plate, the length of the fin, and the thickness of the fin. Make sure to check the units. Some of them are in millimeters, some of them are in centimeters. I just try to put whatever seemed most natural, and I'll convert it later. I also put in two other parameters that technically aren't supposed to be changed, but you can if you want to mess around with the code. This is Q needed. This is the heat transfer rate that's needed in order for the plate to operate, which you can change if you want just to see what it does. This is the spacing. S allowed is the spacing that is needed between the fins. This should be in millimeters. Actually, it is in meters. My bad. There's also one other condition that you can change called tip condition. The end of the fin can have one of two conditions. It'll either be convection or adiabatic. Whatever one you can, I just threw this in here because I figured it'd be kind of nice just to see what the differences would be. Wasn't really necessary for the problem statement I made, but I thought it'd be kind of nice just to be able to change something like that. So those are everything you can change. What's next in the code is just a couple of conversions, just to change it from, say, degrees Celsius to Kelvin for the temperatures, which is right here, and all the distances I change from centimeters, millimeters, whatever it is, to just SI units, meters. This if and else if statement is just here to basically show if you pick convection, you do need to change your length to a characteristic length, which is given in this chart that's in the textbook. So that's what I'm saying here. Just need to correct it if it's a convection end condition. If it's adiabatic, then you actually don't need to change it. Again, that's just in the textbook. It also kind of shows you do need to perfectly type in convection with the capitalization or adiabatic. If you don't, it will get mad at you and actually stop the code right here. It won't let you go any further, and it'll say, hey, you need to make sure you capitalize it, make sure you spell correctly, either one or the two, and it'll stop you and make you correct it before it gets any further. This just calculates the actual spacing that you'll get with whatever fin configuration you picked. And if it is less than S allowed, it won't stop the code, but it'll get mad at you and say, hey, the space between the fins is less than required. It'll still continue on with the code, but it will give you a warning. If it's less than 0, however, that means it's not geometrically possible to make this fin configuration, and it will hard stop the code and tell you to fix it. Going back down, this is just a couple of parameters. The perimeter, cross-sectional area, surface area of the fin are calculated. Then it calculates the M and capital M parameters, which will be used later. Next is the efficiency of a single fin, which I put in the problem statement, something you need to know. That's just calculated with the M, small case m. Next is it calculates all the resistances that you're going to need to know. So, for example, the resistance of the fin itself, the resistance of the base, the resistance of the unfinned portion, and it puts it all into R total. Kind of gives you a total resistance of everything, which is what this line is. Next, it'll calculate the heat transfer rate, and it'll print it to the screen, which is this line. It'll then throw an if statement. If your heat transfer rate over the area of the plate, which is this W squared, if it's greater than what you needed, it'll say the fin configuration is sufficient, and if it's not, it'll say it's not sufficient. Next is, this kind of just gives you the Qmax if the fin configuration wasn't there. And this is just to give you your surface efficiency, which is what these two lines do. And then eta total is the overall surface efficiency, which is something else asked. This line here gives you the base temperature of the fin itself. Since the fin configuration is on a base plate with a thickness, I did ask for the temperature of the fin, how the temperature looks like in accordance with distance of the fin. I asked to plot that. So we're going to need the temperature right at the base of the fin, not just at the bottom of the plate itself, but at the base of the fin itself, which is what this is. Next, it's just another if statement that gives you the correct temperature profile of the fin, depending on whether it's, again, a convection or adiabatic end condition, which is what these two statements do. If you do anything else, it won't actually get down to here, because if you input anything else besides convection or adiabatic, it should have stopped you a long time ago at the top. But if for some reason you don't have one of these two end conditions, it'll tell you to check this capitalization spelling and try again. After that, I'm just plotting the temperature profile and giving it some X label, a title, X and Y axis labels, and just setting the limits, the X and Y limits of what you can see. After that, I put on a legend just to show you the temperature and how it looks. I'll run the code right now. And this is what you should get. It should tell you the efficiency of your fin, the total heat transfer from the heatsink, 124 watts in this case. This tells me my fin configuration is sufficient, and my overall surface efficiency is 0.202. Going back to the figure, we'll see that we have a temperature distribution that looks something like this. This would be the base of the fin itself, not the bottom of the plate. And this would be the end of the fin, 0.3. That's what it looks like. And that's basically what this code does. Hopefully this helps out. And that's about it.